All right, tonight's homework starts with just some simplifying. We're supposed to combine the complex numbers. So I chose the ones that took a little bit of work to add and subtract just to make sure that we're staying on top of our fraction and decimal skills. So 3/4 minus 5/6, I need to get a common denominator, which is 12. So 3/4 becomes 9/12. 5/6 becomes 10/12. We'll do that math. And then for the 7/5 and 1/6. So um, the common denominator is 30. So 42 over 30i, and then minus negative is going to be plus 5 over 30i. We're supposed to answer in standard form, so that's why I've grouped the real part and the real part first, imaginary part second. So real part becomes negative 1/12, and then imaginary part 47 over 30 times I. Right? With decimals, same idea. I'm going to distribute the negative here. So I've got 2.8 plus 13.7i. Distribute this negative. Minus 3.6 plus 15.4i. And you know what? It's okay if the decimals kind of mess you up. So anytime you're subtracting, I'm trying to do 2.8, 3.6. Subtract normally, and then just make note of my answer is supposed to be negative because the bigger number is negative. So remember all this fun borrowing stuff? Borrow from the 3, borrow a 10, so this becomes 16. 16 minus 8 is 8. Drop the decimal down. 2 minus 2 is 0. Again, this should be negative 0.8. If you don't like that, you can also do 36 minus 28. Figure that out. And then remember to put in the decimal points. Okay. 13.7 and 15.4. There's no shame in like actually writing out this work. I think a lot of times we try to do a lot of stuff in our head and it's easy to make mistakes that way. So if you've got room to do it, why not just do the extra work off to the side? You'll see that on my keys sometimes. I don't always trust the numbers in my head to be correct, so I've got to write them down. Okay, 34, we are multiplying. So just going through the FOIL process here. So 2 times 4 is 8. 2 times negative 3i. Negative 6i times 4. Negative 6i times negative 3i is plus 18i squared. Again, I write that down, and then I just go over it and say, okay, but that's 18 times negative 1. I like to write it down first, unsimplified, so I don't, again, make an error in the sign. 8 minus 18 is negative 10. Negative 6 minus 24 is negative 30i. We're multiplying again for number 37, and these are conjugates. So I can give myself a little bit of a shortcut here. If I recognize them as conjugates, radical 2 plus 3i, radical 2 minus 3i, I can skip the whole FOIL process and just do the first and the last because I know that the outside and the inside are going to cancel each other out. If you're not confident with that, then just FOIL the whole thing out. You'll get the same answer. Radical 2 times radical 2 is 2. 3i times negative 3i is minus 9i squared. That's really plus 9. So 2 plus 9 is 11. 42 has a bit of squaring, and then we're supposed to subtract our results. So I chose this one for 2 reasons. I want you to practice squaring binomials correctly, and this subtracting more than one term, people tend to forget to distribute the negative. So let's square these out first. 1 minus 4i plus 4i squared. So I just squared that binomial. Remember, that means you're doing this. If you want to FOIL it out, if you have to see it that way, that's totally fine. Minus parentheses. You need parentheses around this binomial that we square out. These 3 terms are all being subtracted from these 3 terms. So this becomes 1 plus 4i plus 4i squared. And then I'm going to clean up a bit before I distribute the negative. So we have 1 minus 4 is negative 3 minus 4i minus parentheses, same thing here. 1 minus 4 is negative 3 plus 4i. Those are conjugates, but we're subtracting them, so nothing too exciting is going to happen. I'm just going to distribute the negative. So this becomes plus 3 minus 4i. So the 3's do cancel out, but the i's add up to negative 8i. All right, so this, it's not necessarily the squaring that messes people up, although that's easy to make a mistake on. It's subtracting a quantity. So if you multiply before you subtract something, make sure that you're putting parentheses around the thing that you multiplied. Next group of problems are some division problems. So our first one is negative 4 divided by 3i. So we had this in our notes. If you just are dividing by a monomial, you have to rationalize the denominator. And the 3 is not important, nor is the negative or the 4. You're just multiplying by I over I. You're trying to get in the most efficient way possible, get rid of the I in the denominator. So by multiplying by I over I, you make the denominator 3i squared, which makes this negative 4i divided by negative 3, which would simplify to 4/3 I or 4i over 3, whatever. If you have a binomial in the denominator, you can't just multiply by I over I because you won't get rid of the I in the denominator. You'll just put it in a different term. So remember, this is where you multiply by the conjugate of the denominator. So the conjugate is 1 plus 2i over 1 plus 2i. We're allowed to do this, by the way. I don't think I mentioned this in the notes. I've said it before. All we're doing when we multiply the top and the bottom by something is we're multiplying by 1. So multiplying by 1, that's an identity. You don't change anything about the value of the problem. You're just multiplying by a specific version of 1 that's going to help you get somewhere in simplifying. My Algebra 1 teacher in high school, Mr. Enzinger, taught me to put parentheses around binomials like this to help the foiling, help my brain kind of foil it more, distribute, foil, whatever. I don't know, more easily, I guess. So I will pass that wisdom on to you all. You see me put parentheses around binomials a lot. The denominator, we have conjugates, so we're just doing 1 times 1, and negative 2i times negative 2i. In the numerator, negative 14i squared is really plus 14. So 8 plus 14 is 22. 16i minus 7 is minus 9i. The denominator is really 1 plus 4. It should always be addition because you're always going to get, conjugates are always going to be 1 minus something squared, which is for I squared is going to always turn into 1 plus whatever. And then making it officially standard form, we split it up. 22 over 5 minus 9/5 I. Okay, for 58, I can't multiply by the conjugate before I square this out because order of operations says you have to square things before you're allowed to multiply them together. So let's work on squaring this binomial out first. So that's 4, and then 2 times 3i is 6i, so double that. You're going to get 2 of those, plus 12i, plus 9i squared. Clean that up. 4 minus 9 is negative 5, plus 12i. And you could multiply by the conjugate, which would be negative 5 minus 12i, top and bottom, but that's a lot of negatives rolling around. So even though this isn't standard form, you're allowed to make it 12i minus 5. I just rearranged the order just so that you don't have as many negatives. The conjugate of 12i minus 5 is 12i plus 5. A conjugate is just a binomial that shares the same two terms but has opposite signs in the middle. So this is still going to follow conjugate rules where we get where we get a plus and a minus. And then I can fix things in a standard form if I need to. So 5i times 12i is 60i squared. 5i times 5 is plus 25i. Actually, writing it like this set it in the correct order eventually. And then 12i times itself is 144i squared. Negative 5 times 5 minus 25. So I just said we're always going to get something plus something in the denominator. Here we're going to get negative something minus something, which still adds up. Negative 60 on top plus 25i. Negative 144 minus 25 is negative 169. And then when it comes to reducing, it kind of seems like 60 over 169 should reduce, but 169 is not divisible by 3, because if you add up its digits, the rule is that you can add up the digits 1 plus 6 plus 9, which is 16. And if the digits don't add up to something that's a multiple of 3, then it's not divisible by 3, which is kind of a cool trick. I don't know the proof for that, but I'm sure it's on YouTube somewhere. And then 25 over 169 is more obvious to me that 169 is not divisible by 5, so that's out. So that's our final answer. Okay, this section is working with radicals. So we're still just trying to do the math, but remember the rule is that first you need to simplify each, pull out the I first, or simplify each radical, and then perform operations. So since 75 is 25 times 3, this becomes 5i radical 3. And 250 is 25 times 10, so plus 5i radical 10. And radical 3 and radical 10 are not the same, so this is as far as this answer goes. Now, if you want to be in proper standard form, it's supposed to be a real number times I. So if you just like factor an I out, it could be that on our AP exam, maybe there's a multiple choice answer that looks like this. And so you just need to recognize that that's equivalent to the answer that you got. For 66, we're squaring negative 75. So you might just say, hey, the squared cancels out the square root. Answer is negative 75. That does actually work here, but if you want to be official about it, simplify square root of negative 75. It's negative 5i radical 3. Square that, you get 25i squared times 3, and that's negative 75. A problem like this, if this were on a quiz or a test for me, I would just be looking for your answer. I don't quite care how you get there for this problem. Either way is valid. For 68, we're multiplying, but again, remember to rewrite in terms of I first. Okay, so then we distribute. 3 times 7 is 21, minus 3i radical 10, plus 7i radical 5, minus I squared radical 50. Minus I squared is really plus radical 50. And then, so for the real numbers, we have 21 plus, let's change radical 50 to 5 radical 2. That's like the real part. And then let's just do this again with the i's. Say we factor an I out of these two terms. I would write the 7 radical 5 first, minus 3 radical 10. I do want you to simplify the radical 50, and I would like you to put the real numbers first, those first two terms, and then the imaginary term second, whether or not you factor out the I. I don't particularly care about. Again, it's just finding the correct answer in multiple choice. This next section says use the quadratic formula to solve for x, although if I have something that's not a trinomial, I'm not going to waste my time with quadratic formula. For 70, I would just isolate the x squared, use the square root method, and just simplify. Remember my plus or minus and simplify the radical. X is plus or minus 32 is 16 times 2, so 4i radical 2. So that's that. If I did quadratic formula, it would be like the b is 0, and that's just kind of silly, I think. And then I chose these two not to be mean or make it difficult, but I want you to recognize that you should never have to do quadratic formula with fractions or decimals. We're using quadratic formula if an equation is equal to 0. And if you have an equation like this, like it's equal to a number, or it's equal to 0 rather than just equals f of x or something, you're allowed to get rid of the fractions. I'm allowed to say the biggest denominator here is 16, and all of these other denominators are divided into 16 nicely. So if I multiply both sides of the equation by 16, that doesn't change the value of the equation, but it does get rid of the fractions. So 16 over 8 is 2. This becomes 14x squared. 16 over 4 is 4. This becomes minus 12x. 16 over 16 is 1. Plus 5 equals 0. So this clears out the fractions, and yeah, my numbers are a bit larger than I would ideally like to work with, but that's better than fractions, right? So then we apply quadratic formula. 12 plus or minus the square root of 144 minus 4 times 14 times 5 all over 2 times 14. Working with larger numbers like this does just take practice. So here's another reason I wanted you to do this. Again, don't just plug it into the program in your calculator if you have that. You need to have a bit of number sense and like how to work around some of this stuff just to be able to work on problems in case they're on no calculator parts of our exam. So for example, 4 times 14 times 5. I can multiply 4 times 5, make it 20, multiply that by 14. And then in that case, it's just what's 2 times 14? 28, multiplied by 10. Add a 0 on the end. Now, I have the square root of 144 minus 280. Back to subtraction again. Just subtract 280 and 144, and know that the answer is going to be negative, whatever you get when you subtract. Okay, so if you need to show your borrowing, then show it. 10 minus 4 is 6, 7 minus 4 is 3, 2 minus 1 is 1, negative 136. Okay, 12 plus or minus the square root of negative 136 all over 2 times 14 is 28. Now we've got to simplify square root of 136. If you're not sure, just start with 4. Does 4 go into 136? Can go into 13 3 times. 4 goes into 16 4 times. Yeah, so this is 4 times 34. That means I've got 12 plus or minus 2i radical 34. 34 is 2 times 17, by the way, so that doesn't simplify anymore, over 28. Now, if we were to keep this all together, we would divide 12, 2, and 28 by 2 to simplify. Since we're kind of told to put things in standard form, do 12 over 28, simplify that. So those both reduce by 4, you get 3/7, plus or minus, and then simplify 2 over 28. That's I radical 34 over 14. I would accept either answer. You need to be able to find the correct answer in a multiple choice question for AP. 79 is something similar. I don't really want to have, I don't want to have to work with decimals if I don't have to, although this one's not too bad, but I'm going to multiply both sides of this equation. If I want to get rid of a decimal, I need to multiply it by 10 to move it one place to the right. So multiply both sides of the equation by 10. That makes this 14x squared minus 20x minus 100 still equals 0. And then before you dive into quadratic formula, notice that these are all even numbers. So you're also allowed to say divide both sides of the equation by 2. Now it's 7x squared minus 10x minus 50 equals 0. Still, the numbers are a bit large, but better than, in my opinion, better than dealing with decimals or fractions. All right, so 10 plus or minus 10 squared is 100, minus 4 times 7 times negative 50. Wait, is it negative 50? Yeah, well, I have negative 50 there. Hold on, let me check this. I thought I got an imaginary answer for this one. Just making sure I wrote the problem down correctly. That's good. Checking my old answer key. Oops, I should have done plus here. Okay, I caught a mistake in my old answer key, so I will fix that before I post it. Okay, this one is over 2 times 7. So I made my own mistake that this is the reason I want you to practice. We have, I almost wrote -5 instead -50. Here we have -4 times 7 times -50. So this should work out to be 100 plus something, right? So 100 plus whatever I get. And again, you don't have to do 4 times 7 and then times 50. You can do 4 times 50, which is 200, and multiply that by 7. 2 times 7 is 14, and you're multiplying that by 100. So 1400. We're supposed to add 100 to that. 10 plus or minus the square root of 1500 all over 14. Okay, now 1500 is 100 times 15. So 10 plus or minus, there's no I here because this is not negative. So 10 radical 15 over 14. And so x is equal to 5/7 plus or minus 5 radical 15 over 7. So I'll need to double check that answer unless I've made a mistake somewhere here. The answer that I got had an I in it, but I'll need to check that. Double check, and then I'll put the correct version in my posted key. I think this one's right. All right, and then we switch to simplifying just a few more with powers of I. So 2i squared is 2 times -1. 4i cubed is minus 4 times -I. So -2 plus 4i is as far as that simplifies. 84 is kind of interesting because we're not just squaring a square root, we're raising it to the 6th power. So I'm going to take this one first as I radical 2 to the 6th power. Then remember, when you're raising something to an exponent and there's multiplication here, each part gets the 6th power. So this becomes I to the 6th times radical 2 to the 6th. Now I to the 6th, really quickly off to the side, 4 goes into 6 once, the remainder of 2. That means I to the 6th is the same as I squared. So -1. And then radical 2 is like 2 to the 1/2 to the 6th power. That's 2 to the 3rd. So we get -8 for our final answer. Okay, and 86. Let's cube things first. Again, we have to raise to the power before we rationalize. 1 over 2 to the 3rd is 8i to the 3rd. Simplify that. 1 over -8i. Rationalize by multiplying by I over I. And we get I over -8i squared, which is really just I over 8. All right, and then for number 88, I did not rewrite my explanations, but I'll just kind of talk through them. So part A says, here's f of x and g of x. Without actually graphing either function, determine whether the graph of f and g will have x intercepts. So they're not asking, are there zeros? They're asking, are there x intercepts? Does the graph cross the x-axis? So f of x has a vertex at 3, -4. I can see that from the equation. And I just decided to toss in some limit notation here. Instead of just saying the graph goes up from there, because a is positive, the limit as x approaches either positive or negative infinity of f of x is infinity. So that's just me saying graph goes up from there, because you're not supposed to graph it, right? So since the vertex is below the x-axis and then the graph opens up or approaches infinity, the graph has to cross the x-axis. There has to be x-intercepts. I probably have to say something like, because f of x is continuous. G of x has the same vertex, but that graph opens down because there's a -2 in front. So the limit as x approaches the left or the right, plus or minus infinity of g of x is equal to negative infinity. So if the vertex is already below the x-axis and then the graph just opens down from there, it's never going to cross the x-axis. Part B was just solve for each equation set equal to 0. So I didn't erase my work here, but you do not have to square out the binomial and go through this the long way, quadratic formula way. You can just isolate the x minus 3 squared. So I added 4 divided by 2, that's 2. Then you can square root both sides, so plus or minus radical 2. And then you can add 3. So this is what you would get if you did square this out, distribute the 2, combine like terms, and then do quadratic formula. Setting g of x equal to 0, I solve using the same steps, but because I'm square rooting a negative, I get plus or minus I radical 2 as part of my answer, but those are the solutions. Part C says explain how the zeros of f and g are related to whether or not the graphs have x-intercepts. So x-intercepts are where your function equals 0, but they're graphically where the graph crosses the x-axis. So when a function has real zeros, like f, the graph will have x-intercepts. When a function has imaginary zeros, then the graph will not cross the x-axis. And part D, I think I can think of a more concise way for what I wrote out. So generally, for this function, make a statement about how A, H, and K affect whether or not we have x-intercepts. I didn't do the second part, and whether or not the zeros are real or complex. First of all, H, that horizontal shift, has no effect on whether or not the x-intercepts exist. It affects the value of them, but it doesn't make them exist or not exist. It's the vertical shift in which way the graph opens. So basically what I'm saying here is if A is positive, so if the graph opens up and K is positive, vertical shift, so that's this scenario, then you're not going to have x-intercepts. Or similarly, if the graph opens down and there's been a downward vertical shift, no x-intercepts. I could have said if A and K have the same sign. Really? If A and K have the same sign, then you're not going to have any x-intercepts. And because I didn't include this, that means that you're going to have imaginary zeros. And then if A and K are different signs, or K could be 0, right? If A and K are different signs, then f of x will have at least one x-intercept. So if K is 0, then the vertex is the only x-intercept. If K is a vertical or is a vertical shift up or down, opposite of which way the graph opens, then you're going to have two x-intercepts. And that means that you're going to have real zeros. I included this question because this is something that I would imagine these are the types of questions where you're kind of writing some things or writing some rules. This could be like an AP for your response question. Maybe not completely dealing with just quadratics, but definitely some parts of this I would think would show up like that. Okay, if you have questions, please come to office hours or ask at the start of class.